have solved exercise number 1.1. I hope you all understood that exercise. Okay. So in our today's session, we are going to see irrational number. Okay. Now, irrational numbers are exactly opposite of rational number. Rational number in the form of fraction, that is in the form of p upon q, whereas irrational numbers, that is the numbers which are not in the form of p upon q. Okay, that means we can't write irrational numbers in the form of p upon q. Okay, so definition of irrational number is exactly opposite of rational number. Okay, so we can define rational numbers as the numbers which cannot be written in the form of p upon q, where p and q are integers and q is not equal to 0. These numbers are called as an irrational number. So remember students, irrational numbers are not in the form of fractions. There are some examples of irrational number here: root 2, root 3, root 5, pi. Okay. These are some examples of irrational number. Value of root 2 is 1.41 and so on. Value of root 3 is 1.72 and so on. So we can't write each number in the form of fraction. Okay. Therefore, these numbers are called as irrational number. Now look at here, there is no number root 4 since square root of 4 is 2. Okay, and 2 is a rational number. Okay, so root 4, root 9, root 16, okay, are all rational numbers. Only root 3, root 5, they are irrational numbers. Okay, Pythagoras were the first mathematician who discovered irrational number. Okay, so let us see how to locate some irrational numbers on the number line. Okay, so our first example is here. Locate root 2 on the number line. We have to locate an irrational number root 2 on the number line. Okay, for this, make a line or draw a number line. Okay, with appropriate scale 0, 1, 2, 3, 4. Here I magnify the scale. Okay. Now draw the perpendicular at the point 1 of unit length, that is of length 1. Okay. Draw the perpendicular at point 1 and unit length 1. Okay. So call this point as B, call this point as A and join the point OA. Right? Now we get OAB is a right angle triangle since AB is perpendicular on the number line, right, at the point 1. Okay, so we get OAB is right angle triangle. Okay, so my Pythagoras theorem, hypotenuse square is equal to side 1 square plus side 2 square. That means for the triangle OAB here, length of OA square is equal to length of OB square plus length of AB square, right? But length of OB square is 1, length of OA is 1, so 1 square plus 1 square is 2 and length of OA is equal to root 2. So we get length of OA is equal to square root of 2. Okay, so now we have to locate this point root 2 on the number line. For this, use compass. Okay, take the radius OA and draw an arc intersecting the number line. Okay, I repeat again. Use compass, take the radius OA and make an arc intersecting the number line. Okay, so here we get the point P, intersecting point is P and this point shows the number root 2. This way we can locate root 2 on the number line. Okay, now I will show you how to locate root 3 on the number line. Okay, I will show you how to locate root 2 on the number line. For this, we have to construct a perpendicular to the line OA. We have to construct a perpendicular of line at the line OA of unit length 1. Call this point as D. Now join the point OD. Join the point OD. Okay. Now use compass. Use compass and take the radius OD. Take the radius OD and make an arc to intersecting the line. Okay. Now we have to find this point. Okay. For this, let us see here. The angle OAD, the angle OAD is a right angle triangle. Okay, OAD is right angle triangle. Therefore, the hypotenuse or Pythagoras theorem we get OD square. OD square is equal to what? OA square plus AD square. Right? By Pythagoras theorem we get here OD square is equal to OA square plus AD square. That means OA square. Here OA is root 2. That means root 2 square plus here AD is 1 square. That is root 2 square is 2. 2 plus 1 is 3. So length of OD square is 3. That means length of OD is equal to square root of 3. That means this length of OD is root 3. So here we get this point is root 3. Okay. Here we get this point is root 3. Okay. Now let us see how to find or how to locate the point root 4 on the number line. Root 4. Okay. So for this again same procedure. We have to construct perpendicular. We have to construct perpendicular at the line OD of unit length. Okay, length 1. We have to construct the perpendicular to the line OD of unit length. Here, call this point as E and join this point OE. So here we join the point OE. Okay. Then by using the compass, take the radius here OE. Take the radius OE and draw an arc intersecting the number line, right? Draw an arc intersecting the number line. So here we get this point, which is this point is square root of 4. Why this is square root of 4? Since here we get the triangle ODE. Now triangle OED is a right angle triangle. Okay, this length is 1, this length is root 3. So OE is hypotenuse. Look at this here. So length of OE square is equal to what? Length of OD square plus length of ED square. Now OD square is square root of the point root 5 on the number line. Okay, so it's very simple and very easy. Okay, so you students try this at home to construct or to locate the irrational numbers root 2, root 3, root 5, root 5, root 6, so on the number line. Okay. Here the question 1 for the exercise 1.2 is true or false, give reasons. We have given here some statements and we are going to decide whether they are true or false, and we have to give reason for this. Okay, so first statement is every irrational number is a real number. Every irrational number is a real number. Now irrational number means the number which are not in the form of p by q are called as irrational numbers. So is every irrational number is a real number? Okay. Now tell me, real numbers contains all the rational numbers and irrational numbers. Real numbers are formed by group of rational numbers and irrational numbers. So all the irrational numbers are contained in real number. All irrational numbers are contained in real number. That means all the irrational numbers are real number, right? Therefore, our statement is true here. Why? Reason that here reason is all real number contains all rational and irrational numbers. Okay. Now second statement is every point on the number line is of the form of root n, where n is a natural number. Every point on the number line is in the form of root n. The statement is true where n is a natural number. Now natural number contains only positive numbers, right? Natural number contains only positive number. So every point on the number line is of the form of root n. Okay. Now look at here. Square root of 4. Square root of 4 is 2 plus or minus 2. That means square root of 4 is either 2 or minus 2. Okay, but 2 is a natural number. But negative 2 is a rational number? No. That means every point on the number line is not in the form of root n. Okay, since natural number contains only positive numbers. That's why this statement is false. Okay students, you understand this? So result of this statement is false. Okay. Now third statement is every real number is an irrational number. Every real number is an irrational number. Okay. Now take one example here. 5. Now 5 is real number. Again 7. Is the 7 is real number? Yes, it's a real number. But 7 is an irrational number. 5 is an irrational number? No. Since we can express here 5 is in the form of 5 upon 1. 7 is the form of 7 upon 1. Okay. So both here 5 and 7 both are real numbers. But they are rational numbers. They are not irrational numbers. That means this statement is false. That every real number is an irrational number. Okay. So result of this statement is false. Give reason for this. 5 is a real number but it is not irrational number. Okay. So do you understand question number 1? Okay. Now the second question is, are the square root of all positive integers irrational? Are the square root of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Okay. Now consider here square root of 9. result of all positive integers is not irrational number. Okay, and here we consider two examples for this. Okay, so answer of this question is no. New two example here to explain your answer. Okay, now our last question for this exercise 1.2 is show how root 5 can be represented on the number line. Okay, root 5 can be represented on the number line. Okay, so here we have seen how to locate root 2, root 3, root 4 on the number line. Same way we have to locate root 5 on the number line. So dear students, now you have to solve this last question as homework. Okay, I think you all of you solve this example. So in this session we have seen irrational numbers. Okay, how to locate irrational numbers on number line, and we have completed here exercise number 1.2. Okay, so this example number